Hi, so I'm going to be comparing and contrasting the three different types of complement cascades. So to start out with, I thought I would just do kind of a basic overlook of what's happening in these pathways. Excuse me. The complement pathways are actually initiated by proteins that bind to pathogens, and there's going to be a series of conformational changes, which basically are going to result in enzymatic mediators activating other enzymes that are going to generate two very essential proteins that are important in these complement cascades. And these two proteins are known as the C3 convertase and the C5 convertase. And the C3 convertase is going to cleave the C3 into C3A and C3B, and the C5 convertase is going to cleave C5 into C5A and C5B. And what we're going to see is that the cleavage of these molecules is actually going to release active components that will eventually be used as mediators in the functions of complements, and that's going to include opsonization, inflammation, and the generation of even something known as our membrane attack complex or our MAC complex. And so that's basically just a basic overview of what's happening in these pathways. And so now, what are our three pathways? Well, we have the classical pathway, the lectin pathway, and the alternative pathway. And what we're going to see is that each of these pathways is going to start out by being initiated differently, but they're kind of all going to converge in the end to have the same result. So we'll see how they converge in a second. But let's first talk about how their initiation steps are different. So our classical pathway is very unique in the fact that it's the only pathway considered to be a part of our adaptive immune response. And that's simply due to the fact that it includes antigen-antibody formation of those complexes. So our classical pathway is just simply initiated by antibody binding. And four components that are involved in this initiation of the classical pathway are C1, C2, C3, and C4. So now our lectin pathway is considered to be part of the innate immune response simply due to the fact that it's completely independent of any antigen-antibody binding or formation. So how these are going to be initiated are soluble proteins are going to recognize microbial agents. And specifically, that's going to work via these receptor proteins known as lectins. So what are lectins? Well, they're just basically proteins that specifically recognize carbohydrates that are found primarily on microbial surfaces. And so now our alternative pathway, which is also part of our innate immune response, is unique in the fact that it actually has three different distinct pathways by which it can be initiated, and this is called the alternative tick-over pathway is one, the alternative properdin activated pathway, and the alternative protease activated pathway. So what's going to happen is our alternative tick-over pathways are going to be initiated when C3 is going to undergo hydrolysis at its internal thioester bond, and that's actually going to yield the molecule C3H2O. Our alternative properdin activated pathway will be initiated when non-covalent binding of the protein properdin binds to a target membrane, and our alternative protease pathway is going to be activated when proteases such as thrombin or kallikrein come along and activate that. So that is how our three major pathways differ in their initiation steps. So although the initiating event of each of these three pathways is different, they're all going to converge in the generation of the enzyme complex known as C3 convertase. And this enzyme, the convertase, is going to cleave the C3 molecule into two fragments, C3A and C3B. And so what we're going to see is our classical and lectin pathways are actually going to use the same dimer in this C3 convertase activity, while our alternative pathway is going to use a dimer completely different. So our classical and lectin pathway use the dimer C4B2A for its C3 convertase activity, while our alternative pathway uses a different component known as C3BBB to achieve its C3 convertase activity. And although they use different components for this activity, they're actually both going to produce the same end result, which is basically just a dramatic increase in the concentration of C3b, which is basically just a centrally located and has many functions complement protein. And so after this C3 convertase activity has gone through, we're going to go into our part of the cascade known as the C5 convertase. And that enzyme is actually formed by the addition of a C3b components to a C3 convertase. And what is the enzyme C5 convertase going to do? Well, it's simply just going to cleave C5 into C5a and C5b. And C5a is simply just an inflammatory mediator, while C5b is actually known to be the initiating factor of that MAC complex that I discussed earlier. So, as we're going to see, for all three of these pathways, the end result is going to be the same for all of them, which is the formation of the C5 convertase enzyme. But what we're also going to see again is that the classical pathway and the lectin pathway are going to be using the same molecule for its C5 convertase activity, while our alternative pathway will be using a different molecule. And for the classical lectin pathways, the C5 convertase is composed of C4b2a3b, while in our alternative pathway, that C5 convertase is actually composed of C3b, C3b. So, although, as I said earlier, although the composition of the C5 convertases are different, still going to have the same result, cleavage of that C5 molecule into two separate fragments. So, basically, to sum up the end of the pathways, the cleavage of those C3 and C5 are going to release active components that are going to help mediate functions of the complement, as we already saw, opsonization, inflammation, and the formation of that MAC complex. And actually, your C5 is what generates the formation of the MAC complex. And so now I have a diagram to kind of give you a visual overlook of these pathways and their similarities and their differences. Excuse me. So as we talked about, the classical pathway, the lectin pathway, and the alternative pathway, three different pathways, three different ways they're being initiated. Classical pathway with the antigen-antibody, lectin pathway using the lectin proteins, and alternative pathway has three different distinct pathways it can actually take. But what we're going to see is that they're all going to converge at one point and form the enzyme C3 convertase. And as you're also going to see, the classical and lectin pathway are both going to use the C4b2a convertase, while the alternative pathway is going to want to use C3b/BB. But you're also going to see the same end result. That C3 molecule is cleaved into C3a and C3b. And what you're eventually going to see is the formation end result of the C5 convertase. And you're going to see, well, the alternative pathway uses this C5 convertase, while the classical and lectin pathway use the same C5 convertase. And same end result, you can see that C5 being cleaved into C5b and C5a, and then resulting in opsonization and inflammation. Excuse me. So one other thing I kind of researched more on and found about how these are linked into, or these pathways can be linked into stuff we've heard about in today's world is Alzheimer's disease. So Alzheimer's disease is an age-related neurodegenerative disease that actually affects approximately 24 million people worldwide. So a very, very big deal. And they've actually found a way that Alzheimer's disease has been linked to these complement cascades. So a number of different risk factors have been implicated in Alzheimer's disease, but they're actually now finding that neuritic, something known as amyloid plaques, are considered as one of the very defining risk factors in this disease. And although the pathogenesis of Alzheimer's disease is not yet fully clear, it's becoming more and more obvious that the complement system is actually playing a very central role in the amplification of Alzheimer's disease risk factors and neuronal death. And so I have a figure I'd like to show you and how it's going to show the complement system and these amyloid plaques that have been found to be risk or might be able to be causing this disease. I have a figure showing you how those are connected. So what I want to point out here is binding of C1q and C3 to amyloid plaques can activate the classical and alternative pathways of the complement system. But what's actually been found, which is kind of interesting, and that there's no binding of that MBL, that lectin, to amyloid plaques. And so they're actually discovering that this lectin pathway activation has not been reported really at all in Alzheimer's disease. But so basically what they're seeing as the formation of this eventual C3 convertase, which is going to lead that cleavage to the C5 convertase. When that's cleaved, it's going to produce C5b, which is actually a binding site for C6. And by sequential association of terminal components such as C6, C7, C8, and C9, all seen down here, is actually going to eventually form that membrane attack complex. And when that crosses target membranes, it can actually result in osmotic lysis and cell death, which is not good. So that's just one recent study that's shown how these amyloid plaques that have been found in patients with Alzheimer's disease are actually used in the classical and alternative pathways, but they actually haven't been found in the lectin pathways. And Alzheimer's disease is a very big research area, and they're still trying to find ways to help people with it and maybe prevent a cure. And so right now, the study of the research study I've found, they're trying to currently find evolving strategies for design of something known as a complement inhibitor, and they're hoping that this inhibitor might aid in therapy by maybe restoring a fine balance between activated components of the complement system. And they think if they can find that balance between these complement system components, that it's going to improve the cognitive performance of patients with Alzheimer's disease. Yeah, so that's just a little something that extra I found. And that is it for comparing and contrasting the complement cascade pathways, and feel free to use my video. Thanks.